Hello everyone, my name is Harshvardhan. I am pursuing MTech in Metallurgical Engineering Department of IIT BH. I am from Visakhapatnam of Andhra Pradesh. I have done my BTech in Metallurgy and Materials Technology and a diploma in Metallurgical Engineering. So, today we are going to discuss Faraday's laws of electrolysis. So, what are these Faraday's laws? In 19th century, Michael Faraday have formulated two important laws to quantify how much material will be deposited during the electrolysis. So, what is electrolysis? Electrolysis is a process of combining electricity into chemistry together to drive chemical reactions which are not naturally occur. That means those chemical reactions which are non-spontaneous will be driven by electricity. So these Faraday's laws have become backbone of many important industrial and scientific processes, even in metallurgical industries also. Have you ever wondered how metals like copper and aluminum are purified to almost 99.99% purity? Have you ever wondered how coating on jewelries have been made? Have you ever wondered how metals will be protected from corrosion and how water is going to split into hydrogen and oxygen during hydrogen production? All those answers will be given by those two laws. Till the end of this session, we are going to discuss these Faraday's laws and related equations we are going to derive, and we are going to give the applications where these Faraday's laws are serving. And also, at the end of the session, you will be able to predict when you have been given a copper sulfate solution and you have passed some certain amount of electricity and up to certain time, so you will be able to predict how much copper is going to deposit. Is it fun, right? So let's dive into the video. Okay, let's start lecture. Faraday's laws of electrolysis. Faraday's first law. So, the mass of the substance deposited or liberated during the electrolysis is directly proportional to the amount of electric charge passed through the electrolyte. Right. So what it states means mass m proportional to the electric charge, which is indicated by Q. Electric charge is nothing but units of electric charge is coulombs. Coulombs can be written as amperes into seconds, which means electric charge is nothing but current into time. So here we can write it as m proportional to I into t. So to remove this proportionality, we will keep a constant called Z. The Z is nothing but electrochemical equivalent. So what is this electrochemical equivalent? Let's see. This Z can be written as E by F. What is E here? E is equivalent weight of substance. F is Faraday's constant. We know Faraday's constant is nothing but 96500 Coulomb per mole, and this equivalent weight E is written as atomic weight by valency. This can be valency or also called oxidation state of element, or also charge of the ion. So overall equation can be written as mass of the substance deposited equals to atomic weight, let's take atomic weight as W and valency as V. So into 1 Faraday into current into time. This will be the overall equation for first law. So if we go to the second law of Faraday, it states that when we pass same amount of electric charge through different electrolytes, that means different electrolyte means different chemical substances. So the amount or mass of the substances deposited or liberated. Here when we say deposited, that will be discussing about a solid. When we say liberated, that will be discussing about a gas. So the mass of the substance deposited or liberated at the electrodes, at their respective electrodes, is proportional to the chemical weight or equivalent weights of those substances. That means from first law we are writing M equals to Z into I into T. So M equals to ZQ. M is equals to E by F into Q. So when we take it two different substances, which these two different substances obtained from two different electrolytes. So for substance 1 we can write M1 equals to E1 by F into Q. Q is same for both, we have given same amount of electric charge for the both of the cells. So M2 equals to E2 by F into Q. So if we divide both of them, we will get M2 by M1 equals to E1 by F into Q by E2 E1 by F into Q. So finally we are left with M2 by M1 equals to E2 by E1. So like this, second law can be written like this. So what it states means, when we have been given mass of the substance and equivalent weights of the two different substances, so that with the same, when provided the same electric charge, we can calculate the mass of the other substance with respect to one substance. So now from these two, first law and second law, we'll try to solve one numerical. Here it is given, find the amount of copper deposited when 5 ampere current is used for 1 hour to electrolyze CuSO4 solution. Atomic weight of copper is given as 63.5 grams and Faraday's constant is also given. So now let's write the given data. Atomic weight of copper is 63.5 grams. Faraday's constant is 96500 coulomb per mole. So what we know from first law, we know that M is equals to equivalent weight by Faraday's constant into current into time. So let's equivalent weight of copper can be 63.5 by, here valence or the charge of the copper ion. Copper ion charge will be Cu2 plus 2 electrons will give rise to 1 copper ion, 1 copper atom. So here we are giving 2 electrons. So valence, so the charge of the copper ion is 2 and Faraday's constant is 96,500 into given amount of current is 5 amperes into time is given in hours, 1 hour. So 1 into 60 minutes into 60 seconds. So this time is converted into seconds. If we solve this, 63.5 by 2 into 965 into 5 into 36. So we will be left with 5 point, if we calculate this, we will get 5.8 grams. Also so like this we have discussed, like when you have been given a CuSO4 solution and when you have passed certain amount of current per certain amount of time, you will be left with some amount of copper deposited, and you will be able to predict the amount of mass of the copper. So we have done the same here. Likewise, Faraday's laws are helpful in predicting the amount of mass deposited. So let's discuss about some applications. Let me tell you the applications of Faraday's laws in metallurgical industries. Metallurgical field. So, corrosion prevention. If we take corrosion protection, there is this method called electroplating. Also anodizing for aluminum metal. And also coating jewelry, refining or purifying metals like copper, aluminum, etc. If we go to like other industrial applications, battery industries, hydrogen production, etc. So, to summarize the things we have discussed till now, the first law, like the mass of the substance deposited or liberated during electrolysis is directly proportional to the amount of electric charge passed through the electrolyte. We also derived the equation like M equals to ZIT, and from second law we have seen that when we sent same amount of electric charge through different electrolytes, the mass of the substances deposited at respective electrodes will be proportional to the respective chemical equivalent weights. Also, we have derived the equation M1 by M2 equals to E1 by E2. Also can be written as M2 by M1 equals to E2 by E1. So we have solved a numerical, and also we have seen some very good industrial applications from metallurgical industries and also other industries like hydrogen production and also batteries. So I will give you a small task. If you wear any type of jewelry, just see the jewelry or any currency coins, just observe those coins and try to explore how they are made from any YouTube or any other source. Try to just see how those applications, how these laws are used in making of those jewelry or coins. And I will suggest, if you want to explore any further about electrochemistry, I would suggest you to go through any textbooks relevant to the electrochemistry. And yeah, I will post a question at the end of the session so that you can try to solve that numerical. Goodbye.